Thank you very much for the opportunity to present this work. My name is Eugene Jacobson. I'm with the North America Science team of the Nature Conservancy. I'm going to be talking about an online GIS-based tool that we've developed here at TNC to prioritize floodplains for conservation throughout the Mississippi River Basin. So I'm going to talk a little bit about the motivation for creating this tool, and then briefly take you through what it looks like, what it can do, and the data sets behind all of it. So first, what drove us to create an interactive tool focused on floodplain prioritization? I think as many of us know, the Mississippi River Basin has been profoundly transformed to the point where it no longer functions as a healthy river system. There's been tens of millions of hectares of floodplain habitat that have been developed or converted to agricultural use. Thousands of kilometers of levees and floodways have been installed, so that something like 90% of the original floodplain is no longer connected to the river channel. And the effects on water quality have been immensely negative, with ag runoff that used to be intercepted by the floodplain now getting into local waterways as well as the Gulf of Mexico. So there's a huge need in the basin to develop solutions that can address these issues. And one amazing fact, I think, about floodplain conservation is the economic sense that it makes. A recent paper the TNC was involved in has shown that buying up all the unprotected 100-year floodplain in the United States would cost about $156 billion. And if you consider the value of all the property that's anticipated to be developed in the floodplain by 2050, you're looking at about $397 billion of potential flood damages that could be averted. So it's 2.5 times cheaper to protect the land than to recoup all the flood losses that you would eventually see if you built on it. But most of us don't have $156 billion lying around, so resources are limited. So if we want to protect and restore floodplain, where should we do it? And that's where this tool can hopefully help. The backbone of the entire tool is a new 30-meter resolution US-wide flood model that gives us information about the extent of floodplains at multiple return intervals, as well as predicted depth of flooding at each 30-meter pixel of the data. This data set was developed by a research group at the University of Bristol in the UK. And it also incorporates information about levees in the Army Corps National Levee Database. So this this data set is immensely useful for dealing with the fact that FEMA maps of floodplain areas have a large number of gaps in them. And at the same time, its validation rate with FEMA and with USGS flood maps is really high. So it's an awesome data set that we can leverage for all the analysis that we do in this tool. So I want to go ahead and dive into the tool itself. This is an overview snapshot of the user interface, just meant to give you kind of a big picture view. It's pretty simple. You have some widgets on the left that you use to set various criteria. And the map on the right will respond in real time and show you the watershed units that meet all of the criteria that you've chosen. But the first thing that you would do is you would look at the 3 parameters that we have in this red box. First, we have the flood frequency. So you would set the 1 in 5 year, 1 in 100 year, or 1 in 500 year floodplain. And that would be the extent of floodplain that the tool would consider. The watershed size, so we have the Huck 8, which is like the coarsest level, about 3,700 square kilometers on average. Next level down about 90 square kilometers, all the way down to 2.5, the so-called catchment level. And finally, you would set the management action. So if you're interested in protection, it's just going to consider floodplain that's in natural cover, so forest, wetland, or grassland. If you're interested in restoration, it's going to consider floodplain in ag or pasture. So once you've done that, you're ready to dive into some of these other criteria that I'm gonna go through. So first is just the floodplain area. How much is actually just available for us to do work in? If you're looking at protection, it's going to query again based on floodplain and natural cover, which you can see mapped on the left with red being higher. If you're looking at restoration, it's going to query floodplain in ag or pasture. So just to winnow down to those places where there's opportunity. Next, we consider water quality, which is to say nutrient loading. And this data set is based on the USGS Sparrow model, and it tells us about nutrient loading from two different perspectives. First is the loading from each catchment to the local waterway that it flows into. And secondly is the loading from each catchment that actually makes it to the Gulf of Mexico, accounting for everything that gets taken out as it flows down south. And then finally, on the bottom right here, we have this growing degree days metric, which helps us get at temperature throughout the year. Where the temperature is higher, we have higher potential for floodplains to remove nitrogen. So if we want to really target that, we would look at those relatively warmer places. Next, we can also consider the National Commodity Crop Productivity Index, which is a measure of soil's capacity to produce commodity crops based on natural characteristics of the soil and climate. And the idea here is to flag areas with relatively less desirable soils, where the prospect of taking that floodplain that's in ag use, converting it back to natural cover is potentially an easier sell and involves fewer trade-offs from an ag productivity perspective. Next bucket of data is kind of a grab bag of habitat layers from many different sources that we have considered. Important bird areas from Audubon. Then in the top center, places that TNC has identified as having biodiversity significance. Critical habitat for endangered species from the Fish and Wildlife Service. Bird migration corridors. We also have a count by watershed of at-risk wetland species, which are species that have been flagged as imperiled by NatureCerve. And finally, we have an analysis that was done in 2015 that characterizes every stream reach in the US with a fish habitat threat index that looks at anthropogenic disturbances to fish habitat. You can see that mapped in the bottom right. And then the final bucket of data we have really brings in the people side of this. So first, we have calculated how many people live in the floodplain currently, as well as how many people are projected to live there in the future. So in this way, we can see floodplains that are relatively unpopulated now, that might see significant population growth in the future. So if we dedicate those areas to some kind of conservation land use, that would help us forestall those increases in that exposure to flooding. We then use the same reasoning to look at projected property damages in 2050. So here, what we've done is we've brought together flood depth, which is something that we have in our model, with projections from the EPA about where various types of built structures are going to be in the future, which is in part driven by climate forcings in their model. And we have an equation that relates flood depth to damage to those structures. So in effect, what we get is a dollar value 30 years from now of potential flood damages. So this really helps us make, again, that economic case for the value of floodplain restoration by being able to see the potential damage that we can avoid. One final layer we have addresses the risk of flood exposure at the community level. So This is an index of social vulnerability, which looks at demographic variables like income, age structure, education level, how much people pay in rent, and tries to get at a community vulnerability to environmental disasters. So that was a quick run through of the data. Next, I want to give you a really brief sense of the outputs of the tool and the kinds of questions that it might help you think through. So let's say we want to look at sort of like the 1,000-foot view of the basin, and we want to be completely focused on nutrient reduction. We'd go up here to our 3 parameters. We'd probably choose the 1 and 5 year floodplain because it's the most kind of consistently involved in the uptake of nitrogen. We'd set the spatial scale to that coarsest level, and let's just say we're interested in restoration. So the first thing we'd probably do is set kind of just the basic area threshold. There's got to be, in this case, I'm saying at least 5,000 acres of floodplain in ag or pasture. So you can see some places have dropped out. Then we're saying in terms of nutrient loading, both locally and to the Gulf, it's got to be in the top half of the distribution. So there's potential there for floodplains to make an impact by intercepting some of this runoff. And then finally, we're looking at growing degree days. So let's say, show me the places that are relatively warm where the denitrification process is going to be more active. So in this case, we get a footprint that looks something like this. So these are places we think restoration could really increase nutrient uptake. It's warm, there's lots of nutrients coming in, and there's lots of new floodplain that we could restore. But of course, you don't have to limit yourself just to looking at nutrients. There's these other buckets of data that you can bring in to really tell the story of multiple benefits in the floodplain. In this case, I've zoomed in a little bit and I've brought in some of that people aspect. So these are places that have at least 500 people in the 5-year floodplain 30 years from now, as well as $10 million of potential damages, and where the demographics are relatively more vulnerable. So you get kind of a different picture when you bring in those multiple elements. The last thing I want to show is really the power of scale. So we can actually zoom in. Let's say if we zoom into this red box, and we can repeat this kind of process using watersheds that are on average about 40 times smaller than what I've been showing. So really get down to that finer scale. And we can do this one more time if we zoom into this zone, which is around Paducah, Kentucky. Now we're down to units that are as small as 2.5 square kilometers. And at this point, you can see in kind of the gray overlay the actual extent of the floodplain. In this case, it's the 100-year floodplain. So we can actually prioritize at that level as well. So that was kind of a quick taste of the tool. The last thing I want to say is that we see this not just as a decision tool, but really as a communication tool. So something that helps us tell the story of those multiple benefits in the floodplain. And it's not just about, calling up a state emergency manager and saying, here's a bunch of results we got. Now go and do things differently than you have been. Rather, it's about using this tangible kind of science-based thing as a catalyst to open up a broader conversation, build relationships with folks on the ground who are doing this work, and do some exploratory analysis in sort of a collaborative way. So in the immediate future, we're expecting to see some cool new data sets, especially to further flesh out this climate dimension of the tool. Nature Conservancy has done a ton of work to identify lands that we expect to be especially resilient to climate change. That lets us flag places that are kind of more future-proof. Our partners in the UK who developed this flood model have also developed some hypothetical future floodplain extents that account for climate forcings. So we would really be able to see how the shape of the floodplain changes as we introduce some of these alterations in climate. And we also want to take a look at carbon sequestration estimates in the tool as well. And finally, we expect to be developing a handful of local spin-off tools. We've actually completed one in eastern Missouri, which is up and running in the lower Merrimack River. And later this year, we hope to be doing some work on the similar spin-off in the western Tennessee area. So that's pretty much it. I want to encourage everyone to check out the tool. If you go to fptool.org, you can access a page with lots more info about this work, as well as the tool itself. Just don't use Internet Explorer, but you should be good to go. And I hope you all will check it out. So thanks very much for listening.
Great, thank you very much, Eugene. That was very interesting. Again, the Q&A button is on the lower part of your screen. If anybody has any questions, they can type those in, and Doug will be moderating the questions. We have about 3 minutes or so for questions, Doug.
Thanks, Eugene. First question is it possible to integrate other data sets into the tool?
Yes, and so two things is, for at least the remainder of this year, we are funded to continue sort of modifying the tool, kind of treating it as a living document as we touch down with folks on the ground and listen to their recommendations. The tool will continue to grow and change to some extent. And the other thing too is that in the context where we like customize this to a local geography, the framework that we have makes it really easy for us to take some of these coarser national data sets and actually swap in something that's more locally relevant into sort of hang it on the outline of this tool and actually have data that's more useful to a finer scale location.
Eugene, is that something that users can do themselves, or does that take involvement of the people who hold this tool?
Yeah, so we don't currently have the functionality for a user to just bring in their own data and like upload it into the tool and see what that looks like. We are in the process of working on functionality to allow folks to download the results of their prioritization, and then they can locally, you know, drape whatever like data they have. But for now, they would sort of have to contact us, and that's something we handle kind of on a case-by-case basis because that functionality is still in development. So. Okay.
And another question, could this tool be adapted for use in urban areas along rivers for use with projects to help for use with projects such as John Legg described?
I think potentially it could be. In a case like that, the flood model that we're using is probably not the ideal choice because it's not as strong in those urban areas. Like it doesn't consider structures like buildings, walls, curbs. So the more developed you get, the less accurate the model is. So, but potentially, if there was some sort of localized data set, then we could potentially work from there.
Yeah, that makes sense. Good. Thank you, Eugene. I think we're ready to move on.